Hello everyone, welcome to Shim's classes. In today's lecture, we are going to discuss the chapter Determinant and its exercise. So, this chapter is chapter number 4 of Standard 12 textbook of NCERT, and we are going to discuss the exercise 4.1, and the problem numbers which we are going to discuss today would be problem number 5 to 8. In previous lectures, we have already discussed problem number 1 to 4, so please go ahead and watch that video. So, let's start the exercise. So, the concepts are already very clear that we have to evaluate the determinant, and as we discussed last time around as well, when we are evaluating the determinant, we have to look at the rows and columns which will make our jobs easier. So generally we look at the rows and columns where there are multiple zeros, so that the factors which are going to be multiplied will become zeros, right? So in this case what we have here is delta is equals to 3, 0, 3 minus 1, 0, 5 minus 2 minus 1 and 0. So as we can see, this I equals to 1, I equals to 2 and I equals to 3, we call these rows. Along this row we have two zeros. So let's expand our determinant along this so that we can evaluate easily. So what will happen is the first one will become 0 into multiplied by some determinant. The second one will become 0 multiplied by some determinant, and the third one will be, first it will be minus 1 to the power I plus j, so I is 2 and j is going to be 3 here, right? So j is the number of column, right? J is equals to 2 over here and j is equals to 1 over here. So it will be going to be 2 plus 3, 2 is number of row and 3 is number of column, or you can just say 2 plus 3 is going to be odd, so this is going to be odd, right? And then you will have the number minus 1, right? And then finally you will have a determinant. So you will just take out this row and this column. So you will be left with what? You will be left with 3 minus 1, 3 and 5, right? Oh, not 5, just to be aware, this is minus 5. If you make a mistake, then the whole calculation will go for a toss, right? So the first one will become 0, second will become 0, and then third one will become minus 1 to the power. This basically it will become minus 1. This will also become minus 1. And then here minus 5 is multiplied by 3, and then minus of minus 1 into 3, right? This is what it will be. Now this part is 0, this part is 0, and minus 1 will become 1, and then this will become minus 15, and then the final one will become plus 3, so the entire thing will become minus 12, and this is going to be my answer. Let's go to the next one because there are a lot of determinants to be evaluated. Now coming to the second, we'll have to simply evaluate it, right? So we'll have to evaluate 3 minus 4, 5, and then 1, 1 minus 2 and 2, 3, 1. So what we will do is, we will just expand it along this row itself, or we could expand it along this row as well. Yeah, so let's start with the row, the first row itself, because last time we did the second row, right? So we'll take the first one. So this will become minus 1 to the power I is 1, j is 1, so I plus 1, right? Into 3, 3 is the first thing, and then what will be the determinant? I'll have 1 minus 2, 3 and 1. The second part will be, now we know that we'll just look at row and column. So here it is going to be minus 1 to the power odd, so it will be minus 1. I will simply write minus 1, then minus 4. What I meant by power odd is, here I is equals to 1 and j is equals to 2, right? So I plus 1 it will become 3. So either ways you can just write minus 1 to the power 3 as well, into minus 4, and then what will be the determinant for you? It will be 1 minus 2 and then 2 and 1, right? And the third thing will be, it will be 5, and here this is going to be minus 1 to the power even, so it will be minus 1 to the power even. I'll just write into, what will be my determinant? Will be 1, 1, 2, 3, right? So now minus 1 to the power 2 is going to be plus 1 into 3, and then you multiply this 1 with 1, and then minus of minus 2 times 3, right? This is the first one. This is going to be minus 1, this is going to be minus 4, so this whole thing will be plus 4. Then again you have to multiply 1 with 1 and then minus. So I'll just put minus 2 to the 4 minus 4, and there is already a minus here, so plus 4. So I'm going to write in one step itself, and then this is going to be minus 1 to the power even, going to be plus 1, so going to be 5, and then this is going to be 3 minus 2. I'm going to write 3 minus 2. What I did, I multiplied this, right? These two things, right? So now 3, this is going to be 1, and 3 plus 3 to the 6, I'll write 3 plus, and then this is 4 into 5, this is going to be 5 into 1, right? So 6 plus 1 is going to be 7, 7 into 3 is going to be 21, this is going to be 20, and this is going to be 5, so I'll have 46 over here, right? This is going to be my answer. Okay, so let's go to the third one. Third one is going to be this. So here I have delta as 0, 1, 2, minus 1, 0, minus 3, minus 2, 3 and 0, right? Okay, so every row has got 1 0, so every column has got 1 0, so we can expand along anything. So let's do that. And then we will finally observe what is so interesting about this kind of determinant also. So we'll have first one as 0 into multiplied by some determinant, which we do not have to write because multiplying by 0 will be 0. And then this is second, and we also now know that this is I plus j is going to be odd. So simply I will write minus 1 over here, and then what I'll have is I will have 1 over here as well. This is 1. And then I will have a determinant which will be minus 1, minus 3, 2 and 0. And then here I plus j is going to be even. So I will have minus 1 to the power even, or rather write simply minus 1 to the power even, we'll write 1 minus 1 to the power in. And then we will write minus 1, 0, minus 2, 3. Alright. Now this is going to be 0. Now this is going to be minus 1, and then minus 1 into 0 will be 0, and minus 3 into 2 will be 6, but there is already a minus, so I'll write plus 6, right? Minus 1 to the power n will to be 1, and then I forgot to write 2 over here, so we'll have to write 2 as well, which is the 2 over here, right? So this 2 has to be written here, and then multiplying it by 3 minus 1 will be minus 3, and then minus 2 into 0 will be 0, so we'll be having this. So here we will have minus 6. Alright, looks like there is a mistake somewhere. Let's look at minus 1, and then it's minus 1, minus 3, minus, okay. So yeah, so here that should have been minus 2, right? This should have been minus 2, right? Okay, so now I can change this part. This part will become 0, and this will be minus 6, right? Minus, minus, plus and minus 6. So this will become plus 6, and this will become minus 6, and this will be 0. So how do I know that I made a mistake? Is because I already knew the value of this is going to be 0. And why did I know that? Is because this is a determinant of a skew symmetric matrix. So it's a determinant of a skew symmetric matrix. Determinant of a skew symmetric matrix is always going to be 0. So what is a skew symmetric matrix? If you remember, a skew symmetric matrix is when you have A transpose of A equals to minus of A. If A is your matrix, and then if you do a transpose of it and it is equals to the minus A, then it is called a skew symmetric matrix. So let's see what I meant by that. So if this is going to be my matrix 0, 1, 2 and minus 1, minus 2, 0, 3, minus 3 and 0. So if I had to take a transpose of it, right, what would be my transpose? My rows will change to column, column will change to row. So I'll have 0, 1, 2, this row will come to column, this row will come to column, minus 1, 0, minus 3, this one will come to my minus 2, 3 and 0. This will come to my column, this row will come to. Now this A transpose, if I take say, if I take minus common from this, minus 1 common from this, so what will happen here is, I'll have to multiply minus 1 everywhere, right? So 0, 1, 2, this will become minus 1, 0, minus 3, and this will become 2 plus 3 and 0, right? And okay, alright, here it is going to be minus 2, right? Because here it is plus 2, right? Now look at this matrix. This matrix is going to be same, right? So it's going to be minus 1 into A, right? So compare this matrix with this one, right? This is same, right? So this is what minus A. So this A transpose is equals to A minus A over here, right? So this is why it is a skew symmetric matrix, right? And a determinant of a skew symmetric matrix is always going to be 0. So this is a skew symmetric matrix. This is what I was trying to mention. Alright. Now going to the next problem. My next problem is this one. 2 minus 1 minus 2, 0, 2 minus 1, 3 minus 3 minus 5, 0. Alright. So let's evaluate this determinant as well. We have delta is 2 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. Just ensure that you are writing this correctly, because you could see that I have been making mistakes in signs, positive or negative. So just ensure that you don't make that mistake. So in this one, at least in this row I am seeing 1, 0. In this row also I am seeing 1, 0. So I can expand along this row. So let's expand along this row. The first one, if I take 0, so already whatever be the going to be determinant, I don't mind, so I don't write that, right? Plus 2, and what will be my I plus j over here? I is going to be 2 and j is going to be 2, right? So it's going to be even, so minus 1 to the power even, minus 1 to the power even, let's write that, into this one will go, this one will go, so we'll have 2 minus 2, 3 comma 0, and then the third one will be plus minus 1, and this is going to be minus 1 to the power odd, right, into this is going to be 2 minus 1 and 3 minus 5. Okay, so just ensure that everything is written correctly to just ensure, otherwise there will be issues always, right? 2 minus 2, 3 minus 3 and 0, right? Okay, let's evaluate. So minus 1 to the power n is going to be 1, 2 times 2 into 0 is going to be 0, 3 minus 2 with a 0, minus minus plus 2 into 3. So I am just multiplying, cross multiplying this with and cross multiplying this, right? This is what I am doing. Minus 1 is here, and also there is minus 1 to the power, this is also going to be minus 1. And then we will have minus 5 into 10 will be minus 10, and then 3 minus 1 will be minus 3, but there is always a minus over here, so already a minus here, so there is going to be plus, right? Now this is going to be 3 to the 6, 6 into 2 is 12, this is going to be plus 1, and this is going to be minus 7, right? So now my determinant would become 5. This is fine. Let's move on to my next one, next problem. My next problem has got, simply there is a matrix given and I need to find determinant. So when I have to write a determinant A, I will write 1, 1 minus 2, 2, 1 minus 3, 5, 4 minus 9. Alright. Now I have to evaluate this determinant. So what I'll do is I'll expand along one of the rows or columns. I don't see any zeros, so let's take the first one itself. So here 1 firstly, and then minus 1 to the power 1 plus 1 is going to be even. So what I am writing as even and odd is, here I is 1, j is 1, so minus 1 to the power 1 plus 1. So this is what I am writing, minus 1 to the power even. So this is going to be 1. So this is minus 1 to the power even, and then this matrix, this determinant is going to be 1 minus 3, 4 minus 9. The second part is going to be plus 1 into minus 1 to the power odd, and then we will have 2 minus 3, 5 minus 9, and then finally we will have minus 2 into minus 1 to the power even, and then I will have a determinant of 2 by 2 is 2, 1 and 5, 4. So let's evaluate this determinant. Here it's 1 and this is going to be 1. 1 into 1 multiplied by minus 9 into 1, and this part minus, and there is always a minus already, so 4 into 3, and then minus 1 to the power is going to be minus 1, so I'll have a minus 1 over here, and then 2 into minus 9, and then this is 3 minus 3 into 5, but there is already a minus here, so this is going to be 3 into 5, and then finally we will have minus 2 into 1 into 4 into 2 minus 5, 5 into 1, right? So now we will have what? We will have 1 into 1, this is minus 9, this is 12, 12 minus 9 is going to be 3, then here we have minus 9 to the 18, and then we have 15, so this is minus 3, and then there is already a minus over here, so that will be plus 3, and then this is minus 2 into 8 minus 5 is going to be 3, this is going to be 6, this is 6 minus 6, and this is going to be 0. Alright, so wow, so again we have got this entire determinant we calculated, and we got the value as 0, right? Alright, so we will learn later there is a property, and why this became 0 is when you basically when you add column 1 with column 2, then you will get that column to be equivalent to another column, and when their two columns or two rows of a determinant are equal, C1 plus C2 will become equals to minus of C3 actually. This is what will happen, and that is why this entire thing will become 0, right? So this is a property which we'll read later. So yeah, let's do it later. Alright, now go to the 7th problem. Okay, 7th has got two parts. So we have to find the value of x. So it's saying that these two determinants are equal. So what we have to do? We have to equate these two determinants and then solve the equation. So we will have 2, 4, 5, 1 is equals to 2x, 4, 6x, right? So now evaluate this determinant. This is going to be 2 minus 20 is going to be equal to 2x square minus 24. So 2x square is going to be equals to 24 will go that side as minus 8, so it becomes 6, right? And x square will become 3, so x will become plus and minus of root 3. So this is the first one, and this is your answer. Now go to the second one. Okay, we have 2, 3, 4, 5, and this is equals to x, 2x, 3 and 5. Alright, so again evaluate this determinant separately. So 5 into 2 minus 4 into 3 is going to be 12. Here 5 into x is 5x, 3 into 2x is going to be 6x, right? This is going to be minus 2, and this is going to be minus x. Okay, so this is going to be x is equals to 2. Alright, so this is our second one. There is another thing to observe here is, see, when you look at this one very closely, you can see this 2 and x is over here. But look at this. This is 3 here. This is 3 here. This is 5 here. There is a 5 here. And then you have a 4 here and a 2x over here, right? So if you put x is equals to 2, you will see that this and this determinant will become equal, right? So there is kind of observation as well here, but you will see that this is not always true. So always try to evaluate the determinant. So as I said, if you put x is equals to 2, this will become 2, this will become 2 into this is 2x, right? So this will become 4, right? So this was one way of observing, but you will see that this is not always true. Alright, so let's do the next one, which is problem number 8. And here, just like the last time I was mentioning, right? If you can observe, there is a 2 over here. So let me just first write. Again, I have to find the value of x here. So there is x here, 2 here, 18 here, x here, right? Equals to 6 to 18, 6. And if I have simply observed, so I could see there is a 2 here, there is a 2 here, there is an 18 here, there is an 18 here, and looking like this is x, right? This is 6, this is 6. So simply x could be 6 if we are just going by observation, right? But let's do the calculation and see how it turns out. If it had been a matrix, you could have done that, but it's a determinant. Let's see what happens here. So what will happen is, let's multiply, let's solve it. So this x into x will become x square minus 18 into 2 will become 36, and this will be equal to 6 into 6 is 36 minus 18 into 2 is going to be 36, right? This part is become 0, and so x square is become 36, and now x is become less than minus of 6. So if we had just observed and said x is equals to 6, we would have gone wrong. Alright, so the answer here is x is equals to plus minus 6, right? If had it been a determinant, had it been a matrix like this, x to 18x and then equals to 6 to 18, 6, we could have easily said x equals to 6, right? But not in this case, alright? Just be aware of that, alright? Okay, so with this we are done with the exercise. Hope you are able to get what we were trying to do. We were simply trying to evaluate the determinant by expanding it along the columns or rows, and you could try the same exercise by expanding it along either the other rows and columns, and you would eventually see all the time you will get the same value. Alright, so what I mean is, in this case you could have just expanded along this one, minus 2, minus 1, 0, and still you would get the same answer, right? So yeah, do that in your spare time and just figure it out. So thank you for watching this video. If you have any questions, please do ask me in the comment section below, and I'll be happy to answer. Once again, thanks and have a wonderful day.